going to take what we had in the last section and learning or relearning about logarithmic functions, particularly natural logs. And we're going to deal with the derivative of natural logs. And this is a rather interesting scenario. It is actually decomplicates what in your mind is probably coming at you. Two things to keep in mind. It's kind of the reverse of what we dealt with in the last lesson. The derivative of the natural log of x then is 1 over x. Since the integration of 1 over x is the natural log of x, so they kind of go together that way. And here's one that it works out really well. It turns out then, if we keep that in mind, that if we derive, say, u, which is a representation of a part of an equation using the chain rule, then this is going to be equal to 1 over u times du dx. Well, du dx is the derivative of u, so this is going to be u prime over u anytime u is positive. So that means then that we can use natural log functions by using this simple fraction, by finding the representation, taking the derivative of it, and writing a ratio of that to, and that will be your derivative of your natural log function. Now, there's one other thing too that we're going to get into, and that is involving absolute value. The derivative of the absolute value, because this is going to be positive all the time, is going to be u prime over u, exactly the same thing. So this actually makes this pretty easy. How easy? Well, for the most part, very, very easy. So let's take a look at how that works. Start off with the first one. It says derive the natural log of 2x. So that means we need to find out what u and u prime are based upon that. Well, u then is going to be 2x, and the derivative of 2x is 2. So that means then that the derivative of the natural log of 2x is going to be that derivative of u2 over the value of u, which is 2x. 2's canceled out because it's 1 over x. Yeah, it's that simple. All right, do another one. Natural log of the quantity x squared plus 1. Same thing. We decide that u is going to be x squared plus 1. Since that's within that parenthesis there. That means then that the derivative of u is 2x. So the derivative of x squared plus 1 is u prime, which is 2x, over u, which is x squared plus 1. Nothing cancels out. We're done. Now this one's a tad more complicated because now you have a multiplication here. You have a product rule that you have to deal with here. So you're going to take the derivative of x times the natural log of x, and you take the x times the derivative of natural log of x with the x times, derivative of one, the other, blah, blah, blah. Just like I got right there. But that means that x is u, and then u prime then is 1. All right, so I took x here times the derivative of the natural log of x. Well, the derivative of the natural log of x is 1 over x, as we found before. Or if you use that, u prime over u, you get 1 over x. So x times 1 over x, which gives you 1. Now then, you take the natural log of x times the derivative of x. Well, what is the derivative of x? 1. So the natural log of x times 1, which is natural log of x. So our final answer is 1 plus natural log of x. Yeah, that's simple. Now, of course, we're stepping up in complexity here, but we'll get into some interesting ones just a little bit here. But this is not too bad either. Since the x is part of the natural log here, the cube is not. It's outside, it's external. So we make u is x and u prime is 1. So when we start off with the derivative of the natural log of x, since the natural log, we're going to make, that should be natural log of x. Sorry. U equals natural log of x. Okay? And that means that u prime is going to be 1 over x. Okay? So, that means then we go ahead and take u for this, u cubed. That becomes 3u squared du dx. Okay? And so this is going to be 3 times the natural log of x, quantity squared, times the derivative of x, which you said is 1 over x. So that becomes 3 over x times the natural log of x, quantity squared. Sorry about that, I think I was starting another problem there. All right, now this is where things start to get a little complicated, but this goes back to what we dealt with yesterday, and that is expanding these logarithm expressions out, and then taking the derivative of each piece since they're adding and subtracting. Okay, so, and that's what we did here. We have the natural log of x, and it's multiplying here, so this will be a plus here. And this is 2 times the natural log of x squared plus 1, divided by minus. This is 2x cubed minus 1 to the 1/2 power, so the square root is. So 1/2 goes in front, and the natural log of 2x cubed minus 1. Now, we will have different u's for different sections. This is easy. The natural log of x is 1 over x. We don't have to do anything with that. But for this, u squared is 2x is x squared plus 1. So the derivative of that is 2x. So we go through this in 2 times. Remember, u prime over u prime is 2x over u is x squared plus 1. The 2's cancel out. And, I'm sorry, 2's don't cancel out. This is in the numerator. So this gives us 4x over x squared plus 1. Over here, we have 1/2 times this. Where we make u, this is 2x cubed minus 1. So this is u prime over u prime is 6x squared over the original 2x cubed minus 1. The 2 and the 6 cancel out, leave us 3 on top. And that's all we can do with this unless we want to simplify this for whatever reason. In this case, we don't really need to. And I just want to make one comment about this because we've got a problem coming up that will deal with this issue. In the past, I kind of let a lot of things slide because you were getting into something brand new and about half you were freaking out. And so there were some fractions that you created that were reducible that I decided just to let it slide. It was the same thing. In fact, I had kind of sometimes had to back up and make sure you had the right answer, and in which case most of the time you did. But now we're going to have to get into a scenario where you have to be able to reduce fractions. Get your final answer as condensed and reduced as possible. This is not one of those scenarios. There's nothing in common here. We went through and found the lowest common denominator. Nothing cancels out, nothing is gained by doing this. But it's always kind of a good habit to get into to err on the side of overworking a problem. Just saying. Here's the one I'm talking about. We're asked to derive the equation y equals x minus 2 squared over the square root of x squared plus 1. And the way to simplify this nasty little problem is by taking the natural log of both sides. And the natural log of both sides allows you to use that u prime over u formula to get answers that may be more than a little challenging, shall we say. So that's what we did here. So we took the natural log on both sides of this equation, and of course we broke it down like we did, or expanded it like we did in the previous lesson. And so that gave us natural log of y equals 2 times the natural log of x minus 2, division minus 1/2 times the natural log of x squared plus 1. For this one, u is x minus 2 and u prime is 1. For this one, u is x squared plus 1 and u prime is 2x. Okay? Now, here's where the fun begins. We derive that, and when you derive y, you are also going to be using y prime. Natural log of y becomes y prime over y. Now we don't know what y prime, but we do know what y is based on this right here, and that's what we're going to come back to later on. But we're using this right here. The derivative of the natural log of y is y prime over y. U, like the derivative of u is u prime over u. That's where we're getting that from. Now for this one right here, this is 2 times, and this is u prime over u, 1 over x minus 2 for this, minus 1/2 times, and this would be 2x over x squared plus 1. All right, and now we're going to try and combine things because we're going to be introducing a y into this that we have up here at the very beginning. So we will have to make one fraction out of this. So we have, first of all, we're going to get all this resolved here, all these multiplications and fractions and stuff. And we end up with 2 over x minus 2 minus x over x squared plus 1. We go with the lowest common denominator, which is the product of these two. And so that then we find the lowest common denominator. We find the lowest common denominator, and to find the numerators to go with that lowest common denominator, we take x minus 2 into this, which is x squared plus 1. So x squared plus 1 gets multiplied by 2, and that's where we get that expression. Minus x, and then x squared plus 1 goes into this, x minus 2 times, so that x gets multiplied by x minus 2. We multiply all that out. We get 2x squared plus 2 for this, minus x squared plus 2x for this. And when we combine like terms there, we get x squared plus 2x plus 2. Okay? So, that's where we're at with that. Cross that out, because that was a mistake I made earlier on that I caught, but then I forgot to erase. So, now, we're going to get rid of this y here, because we're trying to find the derivative of y. That's the whole point of this. So, we've got derivative of y over y, so we have to, in order to find the derivative of y, we got to get rid of the y. So we multiply both sides by y, so that gives us y squared over, and this is supposed to be x squared plus 2x plus 2 right here, times that. And then that y is that expression right there. So we bring that right here for y. That's the y right there. And you'll see that we have an x minus 2 common factor here.
Teachers, although there is a line, lunch is here in the cafeteria. Thank you.
So if you want to come to school for your lunch in the cafeteria, yeah, go ahead. Anyway, so the x minus 2 cancels out here, leaves us 1x minus 2 up there. Nothing else is resolvable, so our final answer is this. Now, it looks complicated, but these are all basic algebra stuff. Now, of course, as you can see, I made a goof in my algebra early on, which is what that was and that was, but I got it fixed, I found it out, and this is the result. So, be very meticulous, be very slow in doing this, don't be in a hurry to get the problems, and make sure everything adds up and everything's accounted for properly. But there's nothing overtly complex. This is a new process, so it's going to take you a while to get used to that. But it's doable. Now, we're going to do a problem involving square root. So the natural log, we're going to derive the natural log of the absolute value of the cosine of x. And as we found in that one theorem, it's also going to be u prime over u. So we make u then the cosine of x. The absolute value of u, the natural log of absolute value u, when you derive it, is u prime over u. So that's going to be cosine, negative sine x over cosine x right here. And that gives you the negative tangent of x. All right, so lots of fun problems there. Gives you an idea of how to go with this. Your practice problems with these 5 problems. Have fun.